In this video, we want to look at sigma notation, and this is something that I know you've looked at previously, so we want to review some things and then add to it a little bit. So when we have sigma notation is this capital E looking thing, and sigma is kind of a word that means sum. So this is, we're trying to add up a whole bunch of terms. So this is kind of a mathematical way of writing summing something or adding something. The parts of the sigma notation, you'll have a k or a variable 1 to the n, which tells you kind of how many terms you have, and then the a sub k will be a formula. So let's look at an example. So we have sigma is k equals 1 to 4 of k squared. So we start at the 1 and we put 1 in for k, and we have 1 squared. Then you count up. You put 2 in, and you get 2 squared. And then we count up and put in 3 squared. And then we count up and put in 4 squared. So you start at the bottom number, you go to the top number. So this would be 1 plus 4 plus 9 plus 16. Now, when it's written out like this is known as expanded form. So if you were asked to put something in expanded form, this is what you want to do, and you'll want to write it out. If you are asked to evaluate it means you just add all these up and you get 30. So these are the two things we're looking at. We're going to be asked to expand a sigma notation and evaluate a sigma notation. So let's say we want to expand this sigma notation. Now we're going to start at the bottom number, which is 3. So we're going to say 2 times 3 plus 1. And then we go to 4. 2 times 4 plus 1. And then we plug in 5. And we keep going until we get to the top number. So notice we only have 4 terms because we start at the bottom number and we go 3, 4, 5, and 6. Now, if we expand this more, 3 times 2 plus 1, this would be 7, plus 9, plus 11, plus 13. That is our expanded form. And once again, you could evaluate it and figure it out and just get 40. And we're going to do both. We'll talk about in a second. I know many of you may remember from doing this before. Yes, we could get 40 from our calculator. However, we want to do the expanded form so we kind of know what we're doing and we know how to write this out. Now, let's say we don't have a top number. Let's say our top number is infinity. Well, obviously, we can't write out all of the terms. So in this case, when we say expand, we want to write out the first 3 or 4 terms. So we're going to start at 1, and notice we switched our variables. This is I now. We start off, this is going to be 1/3, 1 minus 1, plus 1/3, 2 minus 1, plus 1/3, 3 minus 1, plus 1/3, sorry. I was thinking ahead. 1/3, 4 minus 1, plus ... forever. So if we evaluate these, this is to 0 power, which is 1. So this is 1 plus 1/3 plus 1/9 plus 1 out of 27 plus ... Now, if you notice, this actually is a infinite geometric series. So if you think back to our infinite geometric series, we have this formula to evaluate that. So our first term is 1. We are multiplying by 1/3. So this is going to give us 3/2. Okay. So we can't do this one necessarily on the calculator because you can't plug infinity into the calculator. So we want to expand it to kind of figure out the pattern and figure out what kind of series it is, and then we can use our formulas to solve the geometric series. Now, the other way we can look at these problems is to go the opposite way and say, well, let's write this in sigma notation. So we want to write this in sigma notation. And the easiest way to do this is to start with 1 and then count how many terms you have. 1, 2, 3, 4, 5, 6, 7. So this is the 7th term. Now, to figure out our formula, you want to figure out, just like we did at the beginning of this chapter, you want to figure out what type of sequence or series is this? How do you get the next term? And can you figure out the pattern to get the next term? And in this case, you can see all of these are just adding 4. So that tells you this is an arithmetic series. So we have a formula for our arithmetic series. Our formula was a sub n equals a sub 1 plus n minus 1 times d. So that formula here is 3 plus, instead of n here, we have k times 4. And there is our sigma notation. Here is this series written out in sigma notation. Now, you could simplify this if you wanted to. If you multiplied this out, we would get 4k minus 1. And then that would also work as a formula. So you could go with just the straight formula that we had for arithmetic sequences, or you could kind of try to figure that one out. So another one. 1 plus 4 plus 16 plus 64 plus 256. So once again, it kind of helps if you think of the 1, 2, 3, 4, 5. This is obviously to infinity. So this is k equals 1 to infinity. And now you want to figure out, okay, what type of series is this? How do you get the next term? And in this case, you can see to get the next term, you are multiplying by 4. So that tells us it is a geometric series, and our geometric series, if you remember, our formula was this. So that is going to be 1 times 4 to the n minus 1. And I know you do not need the 1 there, but I just have it there just so it's a little easier for us to see. Now, I do want to point out, many times there's multiple ways of doing this. Instead of using this formula, maybe we could just think about this, and maybe we realize, well, if I just look at 4 to the k, and my k goes from 0 to infinity, you will notice this will also work, because when I put 0 in to start, I get 1, 2 in, or 1 in, I get 2, and so forth, that these both work out to give me the same thing. So you can change this starting number in the sigma notation, and that may change your formula a little bit, but there is more than one way to do them. Let's look at another one. Write in sigma notation 2, 27, 64, 125, 126. So to start off, I always start off with k equals 1, and then this is 1, 2, 3, 4, 5. So we have 5 terms. Now we need to figure out the formula. Now this is a little bit harder, because what we are doing to get the next term is not as obvious. Now, hopefully, as you look at these, you may realize you recognize those numbers. Maybe you recognize that 8 is 2 cubed, 27 is 3 cubed, 64 is 4 cubed, 125 is 5 cubed, and 216 is 6 cubed. So if I just did this down here as k cubed, by starting at 1, this wouldn't work. So instead, I could write this and say, well, let's start at 2, go to 6, and then just do k cubed. If you wanted to start it at 1, is that possible? Absolutely. This would just be k plus 1 cubed. So many times there is more than one way to write these. All right, we want to continue to look at our sigma. We're going to look at a few formulas for sigmas. So these are summation formulas that allow us to add up sigma that have this form instead of having to try to figure out if it's a geometric or anything like that. These are formulas just for this. So if we have k equals 1 to n of a number, this is just equal to that constant times n. So if we had k equals 1 to 30 of 2 using that formula, this would just be 2 times 30, which is 60. Which, if you think about it, this would just be, if I was to write out the terms of this, it would just be 2 plus 2 plus 2 plus 2 plus ... 30 times, which is what the formula is. If we have sigma of 1 to n of k, our formula is just n times n plus 1 over 2. And if it's k squared, it's n plus 1, 2n plus 1, all over 6. So let's use that to evaluate this. So from that formula, it's n plus 1, 2n plus 1, all over 6. And if you put that in a calculator, you get 22/40. Now, I know that some of you are thinking, well, can't we do this on the calculator? And yes, absolutely, right now, we can do this on the calculator. We can use whatever variable we want. I'm going to use x because it's easier than k. So I could put x equals 1 to 40, drop here as x squared. I hit enter. I get the same thing as if I have done 40 plus 1, 2 times 40 plus 1 divided by 6, and we get the same thing. Okay, so yes, I know you can do these on the calculator. So why do we still use a formula? As we go forward, and as we do stuff in the future here, we're not going to be able to just type this into the calculator. That has to do with having variables and things. So we just want to kind of understand these formulas exist and how to use them. You do not have to memorize them. You just have to know how to use them. I will give them to you. Now, some other rules of summation we have are this. The first one says if we have a constant times some formula here, we can take this constant, pull it out in front, and then just evaluate the sigma. So let me show you an example. If we have 1 to 30 of 5k, I could pull that 5 out in front and then just do k equals 1 to 30 of k. So that would be 5 times 30 plus 1 over 2. And then we could evaluate that, and we get 23/25. Or we could just type that into our calculator. Let's look at that just to show it's the same thing. If we went to math sigma and we did x equals 1 to 30 and we said 5x, we get 2325, which is the same thing we get if we plug this in. Now, our second rules of summation says this. If we have a plus or minus, we can split this into two sigmas. So this, when we have a minus in the middle, we can split this into k equals 1 to 40 of k squared minus k equals 1 to 40 of k. And now if we used our formulas, this is 40 plus 1, 2 times 40 plus 1, all over 6, and then 40 plus 1, all over 2, and that equals 21,320. So yes, I know some of these ones we've looked at here at the end, you're able to evaluate them using the calculator. We want to understand how these formulas work for future. We also want to understand how we can write things in sigma notation or expand things in sigma notation to be able to go back and forth. It's more than just being able to, how we're going to use this going forward. It's more than just being able to take this, plug it in the calculator to get that. We need to understand more what's going on when we deal with this sigma notation.